if you look at example 4, name the property used in simplifying. If you look at the steps, we started with the 1/3 being multiplied by the sum of those two items. Well, first we're going to distribute the 1/3 over both of the items within parentheses, which results in something looking like this. Now, it's much easier to think of 1/3 of 3, so I'm going to associate those two things together, which will then give me the property reciprocal result of 1. I associated because I knew I'd get a 1. I know that any number times t will give me t, or any 1 times anything is going to give me the anything, which is why I have the identity property indicated there. And all I am saying now is, therefore, because of these steps, I can transitive property the fact that this is the same as this. So oftentimes, this is like saying in a English paper, in conclusion. Okay? That's oftentimes what the transitive property gives us. So, we're going to do some examples from your book together, and then you'll have some ammunition with which to do your own. Okay, I selected several that I believe would be good for you. Starting with your bold number, your homework number 17. So you're not doing it, but it's number 17. So top of the next page, top of page 18 is where we're going to get started. Okay. If I go through this and it seems too fast, definitely you're going to want to rewatch this tonight and listen to the words because it's going to be fast. There's no way around it. So number 17 starts by saying, I have this. Okay, I have this. And they're trying to get me to the end, which is 1/2 plus t. Now the question is, how do I get from here to there? This problem is set up very similarly to the book's example 4. Okay, they start with this. In your geometry, you would call that like what you were given, and then where you were trying to get to in the end, and that was the end of the thing. And then all of your data is the proof. Okay. So we're going to start with the first thing they gave us, which is this. We have this, and we end up with what they're telling us to do, which is, and whether you write it the same way I do, I don't care. You can copy it the way the book copies it. So, Ben, I'm going to pick on you for a particular reason. How did we get from multiplying 1/2 times the sum of these things to 1/2 times each of these things independently? Yes, sir. This is the distributive property of multiplication in action. We were able to distribute, okay? The rules say I can do that, so I'm gonna. Okay, the next level it still is ignoring this first piece, but it took the 1/2 times 2, and I'm gonna just throw that in there just for clarity, and it had us group those. When you group something, it's like choosing who you associate with. Ashley, what would that be?
Associative.
Yeah. Associative property of multiplication. Okay, distributives and associatives have to do with what it is, multiplication, addition. Okay, so you're going to need to be clear on that. If I'm associating items being multiplied, obviously it's that. Okay. Continuing down the road, I'm just going to leave a space because I feel like I'm writing too big. Their next thing is they've told us that 1/2 times 2 added to, that became a 1 multiplied by t. What property gives this the right to become a 1? What do you think, Dylan? True, we multiplied them, but any number multiplied by its equals 1. What is it? Reciprocal. Yep. This is going to be property of reciprocals. Property of reciprocals state that any number multiplied by its reciprocal gives us a 1. Okay, so we have that now in place. We have that now in place, and we're moving on to our last stage of this adventure.
Yeah. Office. Cabinet. I know.
So that's the mystery part. Anyway, last step. If you take a look at it, it shows 1/2 time, or 1/2 plus, shoot, I forgot to write it there, plus t. Notice the things that disappeared is the times 1 and the times 1. Multiplying something by a 1 doesn't change the item's identity. Dead giveaway. Identity, property of multiplication is your end result there. Okay, so for those reasons, we are able to prove that this is the same as that. Okay, and if you're copying this and you think you're unclear, these answers are in the back of the book as well, so don't think you can't, look at those later. But I'm going to keep moving. Number 19 has 5 steps, A, B, C, D, E. I didn't label these, but you can figure that out. It starts with a given of 1/5 brackets, parentheses, n plus 5, parentheses, added to a negative n, well, I'm sure we're going to use property of opposites later, close brackets. All right, so we start with this, and our goal is to get to a 1. If you look at letter E, our goal is to get to a 1. How do we get from here to there? Well, we're going to start with the first thing they've shown us, which is 1/5, multiplied by 5 plus n plus a negative n. Notice the change. They moved something. And technically, they could move and group in the same step if you write it that way, but they're breaking it out for you. So they moved the order of those guys. Moving is what? Commutative. And we're not multiplying anymore. We are adding. Commutative property of addition. This is commutative property of addition. Okay, and I'm going to move over so I have a little more room to write. Which they then took it to 1/5 bracket 5 and the sum of n and a negative n. Let's add a few more parentheses just for fun. The order hasn't changed, but they have some stuff together. What is that called? Associative, yeah. And it's not multiplication anymore, it's addition. So commuting, if you commute to and from work, you're driving or you're moving. Associative, that's grouping. You choose who you associate with. You choose your groups of friends. Okay, those are your associates, Percy. Exactly right, I can't believe you still remember that. That's awesome. All right. Next, 1/5 of 5 added to 0, and some of those parentheses have disappeared. We've now lost these n's. What law or what property makes that okay? Opposites. You've added a positive and a negative together of the same absolute value. Positive and negative n. They zero each other out. They zero out. Okay? Now, this next step, I, for whatever reason, always have a problem with. Where did the 0 go and why? 5 plus 0 is still 5. Its identity didn't change. Okay? It is that simple. This is identity property of addition. It's that simple. Okay, whenever you're adding a 0 to something and then that 0 has disappeared, that's because the identity of the something still stays the same. Moving on. 1. Why is 1/5 times 5 over 1, 1? Reciprocal. Okay, that's number 19. I'm going to do number 21 as well. Each of the ones I'm doing for you supports the next one. Okay, so each of these that I'm doing supports it, so that it should be really helpful for you to refer back to these 3 samples and the book sample. 21. The starting point is k plus 2 is the same as k plus 2. They started with this given. No order has changed, but they've been regrouped. Percy, what is it?
Associative.
Yeah. Associative property of addition makes this possible. Associative property of addition makes this possible. The next step is extremely irritating to me. Okay, just going to go ahead and lay it out there. They then did, well, 1 times k plus 1 times k plus 2 is still okay to do. And what they're trying to lead you to is the fact that by multiplying something by 1, you still have the original something. And the reason they're making this an issue is going to be more clear in the next step. This is the identity property. Okay? The identity property states multiplying by 1 is okay. This one's tricky. This one's a little bit tricky. Not only did I kind of move those ones, which you might think is associating, I also grouped them. Okay? So kind of in your mind know that, yes, I associated them, but the end result then was the grouping of these two numbers, and the grouping, yes, I commuted them, but the grouping and the pulling out for the sake of the multiplication led us to the distributive property. Okay, so I know I commuted them outside. I know that I then associated them together. Okay, but the result is the fact that they are now to be distributed over the k plus 2. This one is rather tricky. By replacing the 1 and 1 with the 2, 2k plus 2. Replacing the 1 and 1 with the 2, I have now substituted 1 plus 1 is 2. 1 plus 1 is 2. Just ignore the squiggle. 1 plus 1 is 2. Remember, the 2 is only going to get multiplied by the k. I'm sorry if I misspoke a moment ago. The 2, based on this, is only going to get multiplied by the k, because there are 2 k's in the beginning in this addition phrase. The 2 replaced or substituted in for the 1. I just gave it away. This is the substitution principle, which states that another, or just substitution, they wrote it in, which states that a simpler version is okay to substitute in for something. All right? I can now pull the 2 back out. You know how we used to factor? Well, I have now factored by using the distributive property. Okay? So some of these steps, and I'm kind of expecting this, you know, you might get some slightly, like if you guys had said this, then one of these, then somehow you would have to get to the fact that these were pulled out and distributed. I'd have to look at your whole proof to kind of figure out where you were going with it, but some of these might be slightly tricky. I highly recommend you talk to one another on these so that you're able to best answer the questions. Did I? Whoa, whoa, whoa. 2K plus 2 times 1. You're right here. Goofy girl. Thank you. 2K plus, thank you, 2 times 1. And multiplying something by 1 is the identitive property. You know, and think about what has changed from the above. Thank you for showing me that. Think about what's changed from the above, because every time you're able to see, oh, they're multiplying it by 1, anything times 1s keeps the same identity. And I'm not even sure why they even had to show that step. I guess they just wanted to show that you can pull the 2 out. I don't know. Number 23 is an awful lot of steps. You can get that one from the back of the book. I don't want to necessarily go over that and take too much more of your time, okay?